who's ready for another free response? Natural gas is the cleanest burning fossil fuel. Coal and oil, the other fossil fuels, are more chemically complicated than natural gas, and when combusted, release a variety of potentially harmful air pollutants. Since natural gas is mostly methane, CH4, the combustion of natural gas releases fewer byproducts than other fossil fuels. Part A. Write the balanced chemical equation for the combustion of methane, CH4, with oxygen. Easy. CH4, gas, plus oxygen, gas, don't forget it's diatomic, is going to form carbon dioxide, gas, and water, gas. Really important that you can recognize a combustion reaction reacting with oxygen, forming carbon dioxide and water. Let's balance this. Initially, with a coefficient of 1 for each of my reactants and products, that gives me 1 carbon, 4 hydrogen, 2 oxygen on the reactant side. On the product side, 1 carbon, 2 hydrogen, be careful, 3 oxygen. Carbon, balanced. I'm going to go to hydrogen next because it appears only once on either side. To balance my hydrogen, I'm going to put a coefficient of 2 in front of water. That balances my hydrogen, but recognize that it also changes my total number of oxygen on the product side to 4. The only thing unbalanced now is my oxygen, 2 on the reactant side, 4 on the product side. A coefficient of 2 in front of oxygen will bring balance to the oxygen as well. Balanced. Part B. Draw the Lewis structures for methane gas, CH4, and oxygen gas in their respective boxes below. Oh, it's a throwback to the good old days of first semester chem. Let's do this. CH4. I'm going to set it up. I've got carbon, hydrogen. Carbon has 4 valence electrons. Hydrogen has 1. I've got 1 atom of carbon, 4 atoms of hydrogen. I've got 4 total valence electrons to work with from carbon, 4 total valence electrons to work with from hydrogen. 8 total valence electrons to work with in my molecule of methane. Divide that by 2, I've got 4 pairs to work with. All right, I'm just going to remind myself 4 pairs up here in the corner. Carbon's going to go central, surrounded by my other atoms. Connect them all with a pair. It takes me 4 pairs to do that. I have no pairs left. Woo! Double check. Carbon has an octet. Hydrogen doesn't, but that's okay. Hydrogen's only going to have a max of 2. Lewis structure of methane, complete. Let's do oxygen. Remember, diatomic. Oxygen's got 6 valence electrons to start, and there are 2 atoms of oxygen in a molecule of diatomic oxygen, which means that 12 valence electrons to work with. Or 6 pairs. All right, I'm going to remind myself 6 pairs. We don't really have a central atom here because there's only 2, but I'm going to initially connect them with a pair. That uses up 1. I've got 5 pairs left. I'm going to put 3 pairs on this oxygen so that it has 8. 2 pairs on this one. Used up all my pairs. I have no pairs left. Woo, I'm done. Nay, check carefully. Oxygen must follow the octet rule. The oxygen here does. The other oxygen does not. But I don't have any more pairs to give it. You can share. Remember, if you run out of pairs and you still need an atom to have more electrons, create multiple bonds. I'm going to take a pair from this oxygen. I don't want to give it to just this one by itself. I'm going to make it share. Lewis structure for oxygen, complete. Subpart I, identified the molecular geometry for methane. Well, let's count up the regions of electron density about our central carbon atom. 1, 2, 3, 4. All bonding regions, no lone pair regions. That means that this one, tetrahedral. Woo! Subpart II, identify the molecular geometry for oxygen. We only have 2 atoms here. We don't really have a central atom. It's going to be a linear molecule. Boom. Molecular geometry for oxygen, done. I don't know about you, but that was a great trip down memory lane. Lewis structures, geometries. It just gets me teared up thinking about all the good times I had first semester. Gasoline is a transparent, petroleum-derived liquid that is used primarily as a fuel in internal combustion engines. It consists mostly of organic compounds obtained by the fractional distillation of petroleum. Pentane, C5H10, a 5-chain hydrocarbon, is one of these organic compounds that is often blended into gasoline. Write the balanced chemical equation for the combustion of pentane, C5H10, with oxygen. Oh, combustion! C5H10 reacting with oxygen to form carbon dioxide and water. Again, you want to be comfortable with recognizing a combustion reaction. What do you need on the reactant side? What do you need on the product side? All right, let's balance this. If we had coefficients of 1 for each reactant and product, on the reactant side, that would be 5 carbon, 10 hydrogen, 2 oxygen. Product side, 1 carbon, 2 hydrogen, 3 oxygen. All right, remember, we're going to save hydrogen and oxygen for last in most cases. So let's try and balance the carbon first. Coefficient of 5 will change my carbons to 5 and bring them to balance. My total number of oxygen, I've got 10 plus 1, 11. Let's balance hydrogen next because it appears once on each side of the equation. Oxygen appears once on the reactant side, twice on the product. 10 hydrogen on the left, 2 on the right. Coefficient of 5 will balance my hydrogen. Changes my total number of oxygen, though, to 15. 10 plus 5. Oh man, what did I do? There's no whole number times 2 that will give me 15. That's it. I give up. You can do it. I can do it! Remember that when you get in a situation like this, it's sometimes helpful to use decimals or fractions to get the equation to balance. So even though there's no whole number times 2 that will give me 15, 7.5 times 2 will give me 15. Woo! So we're balanced. However, we do want to balance using the smallest whole number ratio. So now let's think about what factor could I multiply every coefficient that I have here by in order to turn them all into whole numbers? Answer, 2. So if I multiply this invisible coefficient of 1 by 2, I get 2. If I multiply 7.5 by 2, I get 15. 5 times 2, 10. 5 times 2, 10. Now, if you're unsure whether that works or not, just go back and double check. 2 times 5, 10 carbons. 10 times 1, 10 carbons. 2 times 10, 20 hydrogen. 10 times 2, 20 hydrogen. 15 times 2, 30 oxygen. 10 times 2 is 20, plus 10 times 1, 30. Winning at life. We are done.